our initial, this is what we're going to build from the ground up in the chassis. So this is what our drive system is going to look like. Okay. So now we need to move more into the top half of the robot and its interaction with our mini bot. We also decided on Monday that we are going to definitely try to have a mini bot, and we are going to try to be a scoring robot. So we're going to have to design that top end to take into consideration that mini bot on our robot.
Do you want to explain the transmission choice into more speed versus torque? So choice you made on that, or is that?
Well, with our target speed of 15 feet per second, we looked at torque versus speed, and it's a relationship. You can only motor puts out so much power. You can put it all into speed, or you can put it all into torque. And torque gives you acceleration, and it gives you pushing ability. If you have too much speed and no torque, the motor won't even, it won't even allow the robot to move. So you can't have zero torque. If you got zero torque, you just stall the motor. All right. So we're looking at about 2/3 of the way between the spectrum out of the power of the motors, from between torque and speed and the high end of the speed. And we're going to try to produce 15 feet per second as our target speed of the robot.
I like the telescoping arm better than both the others because the telescoping arm against the single jointed locking arm, it allows us to be able to retract it, and that would make our center of gravity, it wouldn't be out so much, so then that might help us if we're top heavy. And also against the double jointed arm, I mean, the double jointed arm would do the same thing, but as we said earlier, the telescoping would be easier to control.
And over other robots, which we are looking at, we shouldn't have to do. But as a firefighter, knowing how I needed to manipulate a ladder that was not articulating, it really cuts down in your range of motion. You see these bucket trucks that for Edison, when they have an articulating arm, you know, they can go up and over a wire, and if you have a straight arm, anything that you need to go in between or around or over, you're pretty much done. This game might not require that, though, so it's not to say that it's not a bad thing altogether.
And then it's closer, but we still have a bar going out that way. Like, you could have the guide bar, so
it could be on the guide bar.
It could be a guide bar and then that lever.
It could be on,
and then they're overlapping.
This end of the
fold
surgical
together.
tubing could be on the guide bar.
All right, yeah, that works.
Does that work?
Yeah.
Okay.
Just have to get some
Now,
In my mind,
pieces.
and this doesn't mean it's right. This one in my mind, when I talked about the space in the robot,
What?
when you have a vertical,
So what are we thinking, guys? So we kind of have like 3.A and 3.B. We kind of it's sort of two variations of a similarity.
Basically, we have the same. We have
The same.
two flat parts,
Yeah.
one round that comes around.
It's 3.A. Just the question is, how does again? We have two different ways of the third one latching on.
Pretty sure that's not good.
Something like
Perfect.
What
like
what
that,
happened to you?
and then
Is it from metal?
No, I think I just
Or-
like picked it off.
Oh, okay.
the other one would be
No.
a V-notch in here.
two-dimensional, so it's a little bit harder to, but at the same point, we could put something in underneath, because the mini-bot's here, we could put something underneath this way. So you gotta change your train of thought to say, okay, well, I like this flat thing but now we rotate it this way, and we really have the same space, and then that motion is going through there. So,
Oh, right there, right there.
so visually, in my mind, I like this vertical really
The only thing that
well.
would really like that dimension that we'd have to worry about is just space into the robot. Like I said, we need a little bit more to overlap. But the width depends on the mini mod and the height depends on the size. So it all really depends on just depth and the size.
And realistically, all the width only has to be where the minibus's going to sit. The rest of it doesn't have to be that full width.
Right, yeah, we said we could work with one depending on how heavy you're.
But then, if anything else, depending on how big the other minibot is, we'll just have one.
5 minutes to wrap up.
All right. So you guys know what he's saying, right?
Yes.
Only get the cooperation points if it works.
Oh, really?
And the cooperation points only count toward the cooperation award.
We have to do that word too.
I wasn't thinking so much as like to help other teams, not to be selfish, but like if ours breaks, we can borrow another one. If they're not in the playoffs or anything, we can just borrow it. Not to
Which would be 30 points.
Yeah.
Could mean 30 points, Dave.
We don't want to make you.
That's an even better reason to do it.
Or we could just build a backup.
Yeah.
Like 469 is gonna do.
Could build two. All right, anything else on the priorities?
No.
Is anybody writing this stuff down?
I'm filming it. Did you just call me child? Child. A child's got it on video.
All right, ideas for design.
Little baby. Whoa. I just zoomed.
Having two wheels on like varying heights so that, and then weight on one side so it pulls down on one of the wheels and that's how we get the friction and then both the wheels spin.
You guys all catch that?
Yeah.
Two
Okay,
wheels,
yeah,
high
do you
and
want-
low, with weight on this end, so that it pivots, so your pole is here, so you can set it up this way, and then the weight would pivot it, which would press the lower wheel to the pole, and the top wheel to the pole, and then those two wheels drive the thing up. What kind of wheels?
Andy marked 6 inches.
Andy marked 6 inches. Are you gonna be able to center that?
Yeah, I know, it's 12 inch, oh, Tetrix wheels.
Which ones?
The ones that will work well.
We are limited, to a specific kit of parts for our minibot, which we don't currently have. So we can't look at it. But if you read the rules, you would know what they are.
All right, my idea, the best way to describe it is have like a, it's probably best if I draw it, but it's pretty much two levers.
Let's go. I can jump on your back.
All right, so the open position is we have a lever like this, and it guides, like here's the pole. It will guide the robot, like if we're too far on one side, it'll hit, direct it in. And then when we hit the pole, these will fold in, so they wrap around. We could have rollers on this, so it'd be like, here's the pole, and then here's the levers now. And then we could have, best way to describe this is like a rocker button, but have a piece of surgical tubing here that's tensioned, and then it'll hold them in place. We could have it so without the pole in there, it's in further than the diameter of the pole, so it keeps tension, and you have the wheels right here, and the motor powering it, rollers on there.
Non-powered at
Yeah, non-powered rollers on here, but the wheel would be powered. All right, so we're in the atrium testing our tubes, seeing how well they're thrown.
Ready? 1, 2, 3.
The circle does work. That's beautiful. 54. But this, how long's the safe zone? Like 7 feet, pretty much. So pretty much we have to go 47 feet.
Back up. Yeah, exactly. I'm gonna do that. That's the best way to throw it.
Yeah, it is the best way to throw it.
I know, but if you miss it.
The white one's the best to throw because it rolls.